So we're going to take a look at this question from section 4.1. This really doesn't require any writing, so I'm just going to try to talk us through it here. It says use the given information in the figure to find the following values. So we want to find f of 1, f prime of 1, the domain of the function, and the range of the function. So let's take a closer look at the function. F of 1 is probably the easiest thing to find here. Keep in mind that the function is this blue part here, and this light pink line here is the tangent line. Okay, so f of 1, just go to 1, and we see that the point 1, 3 is on that graph, so f of 1 is equal to 3. F prime of 1 is the derivative of the function at x equals 1, and that's where this pink line comes in. So the derivative, remember, is the slope of the tangent line, and this is the tangent line. So basically the question for the second part just asks us to find the slope of this line. Okay, well, we can do that by just noticing which sort of vertices that this thing is crossing through. In other words, which grid lines, intersections that this pink line is going to cross through. So clearly it crosses through this one at 1, 3, and the next one that it's clearly crossing through is right up here in the very corner. Or if you wanted to, you could go all the way down to that one right there. Either of those is going to be fine to determine the slope of this line. If we start here, we see that we have to go up 1, 2, 3 units, and then to the right 1, 2, 3, 4, 5 units. So remember that the slope is the rise over the run, so the slope of this line, we said we had to go up 3, that's 3, and then right 5, so 3/5 would be the slope of this line, and therefore that would be the derivative of the line at x equals 1. Okay, so let's just make absolutely sure of that. We said that f of 1 was equal to 3. We can check that answer. Good job. And then we said 3/5 for the other one, so let's enter that as a fraction. 3 over 5. And hopefully that's correct too. Yep, nice work. The domain, let's come back to our graph to look at the domain. So remember, the domain is is all the x values where the function is defined. The function starts right here at x equals -3. Okay, there's no graph of the function, at least over here to the left of -3. So that means the graph starts at x equals -3 and it goes forever. That arrow indicates that it's going forever. So the domain of this thing will be -3 to infinity, including -3. Okay, so let's make sure. So the domain, we're going to write this in interval notation. We can write it as, let's see, how do we do interval notation on this? We'll use the bracket -3 and then infinity. Check the answer. Nice work. And finally, the range of the function. So remember, the range is the set of all the y values for which the function is defined. So notice that the graph does not go below the x-axis. There's no graph at all below the x-axis. So that means that the graph starts at y equals 0, and again, that arrow indicates that it's going to keep going up forever. So the range on this thing will be 0 to infinity. And we'll just make sure of that. We'll type in 0, infinity. And close parentheses. Remember that you can never include infinity as any endpoint of an interval, so always going to have a rounded bracket on that. And sure enough, we get that. So that is this problem.